I welcome you to Integrative Theology. This is Class 4, Lecture 8, Supplemental Lecture 2. I am your host, Bishop Dr. Derek A. Reeves. Let's dive right in. Today's supplemental lecture, Lecture 2, or the Supplemental Lecture 2, Scientific Method, and we're going to deal with Popper and Kuhn. Let's dive right in. The scientific method is often presented as a straightforward recipe where you observe, hypothesize, experiment, and then conclude. But the actual epistemology is far more complex and contested than what seems to be. Let us examine or explore this through the contrasting yet complementary lens of Popper and Kuhn. The method is far more complex, social, and philosophically loaded than it appears in textbooks. The standard scientific method, in its most basic form, the scientific method is a systematic process for investigating the world. It generally follows these steps. Number 1, observation, noticing a phenomenon or a pattern. Number 2, question, asking why or how this happens. Number 3, the hypothesis, proposing a testable, tentative explanation. Number 4, prediction, deducing what should happen if the hypothesis is true. Then we come with experimentation, testing the prediction through controlled data. Number 6, analysis and conclusion, determining if the data supports or refutes the hypothesis. The idealized scientific method involves systematic observation, pattern recognition, hypothesis formation, experimental testing, and theory refinement. Francis Bacon championed induction, gathering observation to arrive at general laws. The logical positivists of the Vienna Circle emphasized verification. Meaningful scientific statements must be verified through observation. And so when we look at the scientific method, we have observation that leads to hypothesis. Hypothesis can lead to theory and scientific law, or the development of scientific law. When we go back to hypothesis, hypothesis leads us to the experimental, and the experiment then leads us to the conclusion, which can take us back to the formation of theory and the production or the construct of scientific law. Karl Popper, in his Science as Falsification, Karl Popper in 1902 to 1994 revolutionized the method by arguing that science is not necessarily about proving things true, but about proving them false. The problem of induction, according to Popper, he argued that no amount of supporting evidence can ever prove a theory, that is, seeing 1,000 white swans doesn't prove all swans are white. And so he believed that there had to be a falsification or falsifiability for a theory to be scientific. It must be capable of being disproven. If a theory explains everything, like some forms of psychoanalysis or astrology, Popper argued it isn't science, it's pseudoscience. And so we look at the method. In Popper's view, a scientist should make bold conjectures and then spend all their energy trying to destroy them. The theories that survive this trial by fire are not true. They are simply corroborated for now, according to Popper. And so Popper's motto was, science progresses through conjectures and refutations. Karl Popper fundamentally challenged this inductivist picture. His key insights were the following. The problem of induction, he said, no amount of confirming observations can prove a universal law. We've observed countless white swans, but that doesn't logically guarantee that all swans are white. And indeed, black swans do exist. Induction, according to Popper, can't provide certainty. Then there is the falsification, not verification. Scientific theories can never be proven true, but they can be proven false, according to Popper. A single black swan refutes all swans are white. Therefore, what makes a theory scientific isn't that it can be verified, but that it's falsifiable. It makes risky predictions that could, in principle, be shown to be wrong. Then there are conjectures and refutations. Science progresses not only by accumulating verified facts, but through bold conjectures subjected to provisionally and accept those that survive. Scientists should be trying to break their theories and not confirm them. Then there is demarcation. This gives Popper a criterion for distinguishing science from pseudoscience. Marxism and psychoanalysis, he argued, weren't scientific because they could explain any observation. They weren't falsifiable. Einstein's relativity, by contrast, made precise predictions that could have been proven wrong. Corroboration versus confirmation. Theories that survive rigorous testing are corroborated, not necessarily confirmed or proven. They've earned provisional trusts, but remain forever open to refutation. Popper's view is bracingly rational and critical. Science becomes a Darwinian struggle where only the fittest theories survive. It also captures something real about scientific practices, the emphasis on rigorous testing, the value of null results, the recognition that we can't prove theories definitely. And then we come to Thomas Kuhn, Science as Paradigm Shifts. Kuhn's Paradigm Shifts. Thomas Kuhn, The Structure of Scientific Revelations, or Revolutions, 1962, offered a radical different picture based on actual historical science. Normal science. Most scientific work happens within a paradigm, a comprehensive framework, including theories, methods, standards, exemplary problems, and solutions. Think Newtonian mechanics or the Darwinian synthesis. Scientists within a paradigm don't constantly question foundations that they do. Puzzle solving within accepted frameworks. And so he says in most scientific structures, scientists don't often try to prove their theories or hypotheses inadequate or wrong. For the most part, science is done, according to Kuhn, to prove that a theory is correct. Paradigms are income measurable. And so when he says income measurable, he simply means different paradigms don't just disagree on answers. They ask different questions. They use different concepts and apply different standards. Aristotelian physics and Newtonian physics aren't straightforwardly comparable. They're different ways of doing physics. And according to Kuhn, anomalies and crises exist. Normal science accumulates anomalies, observations that don't fit the paradigm, and usually these are set aside as puzzles to solve a little later. But if anomalies accumulate and seem fundamental, the paradigm enters a crisis. And so Kuhn then, with revolutionary science, he says a crisis can trigger a paradigm shift, a wholesale replacement of the framework, the shift from geocentric to heliocentric astronomy, from phlogiston to oxygen chemistry, from Newtonian to Einsteinian physics. These aren't just theory updates. They're gestalt switches in how scientists see the world. Theory choice isn't purely rational. Since paradigms are incommensurable, you can't straightforwardly or forwardly test one against another on neutral grounds. Scientists switching paradigms are influenced by factors, according to Popper, would call them non-rational, aesthetic appeal, problem-solving promise, generational change, even social and political factors. And so the non-linear progress. Science doesn't simply accumulate truths. Revolutions involve loss as well as gain. Questions the old paradigms that could address might become meaningless with new paradigms. Kuhn's account was deeply disturbing to many philosophers because it seemed to undermine scientific rationality and objectivity. If theory choice involves non-rational factors and paradigms are incommensurable, is science just mob psychology? And so, when we look at Kuhn, he said, within the Kuhn cycle, he said there is pre-science, which is normal science that moves to the model drift, that moves to model crisis, that moves to model revolution, and then the paradigm change. And the paradigm change can go back to the model revolution and start the process all over again. And so the nature of science, according to Karl Popper, was a logical process of elimination. According to Thomas Kuhn, it was a social and psychological process. When we deal with scientific change, we deal with, according to Popper, rational and continuous change. When we deal with Thomas Kuhn, he said, revolutionary and disruptive. When we deal with the scientist's role, Popper said, a permanent critic, a skeptic of even their own ideals. Thomas Kuhn said, a puzzle solver within a framework. When it dealt with progress, Karl Popper said, getting closer to the truth. Thomas Kuhn said, moving from one framework to another. When we deal with philosophy, Karl Popper said, philosophy was prescriptive, how science ought to work. Thomas Kuhn said, in his descriptive, he said, in philosophy, science is descriptive, how science has worked. Why this matters today. This philosophical tension is visible in most modern debates. When people say, follow the science, they are often thinking of Popper's idealized objective version. However, when we see scientific communities resist new data or fight over funding and prestige, we are seeing the Kuhnian social paradigms in action. So what does follow the science literally mean? comes from the two different schools of thought. Follow the science could be following the political narrative that is based on the foundation of who supports the theory. And then when we deal with, from the pauper point of view, following the science then is how science should work. But we find that science and the scientific theories of our day are highly, dramatically influenced by whoever controls the narrative. And this is all we have for today. I thank you for joining us. This is Integrated Theology. I am your host, Bishop Dr. Derek A. Reeves. Until next time, God bless you.